In the summer of 1872, on the East River between Manhattan and Brooklyn, men were trying to do something that still sounds unreasonable even now. They were raising two masonry towers out of open water until they would stand roughly 276 feet above the tide, taller than most buildings in New York, not with modern cranes or welded steel frames, but with timber, derricks, ropes, pulleys, steam power, chisels, hammers, hand-cut stone, and human bodies. Below them the river ran hard with current and traffic. Above them gulls crossed the wind. Around them ferries, tugboats, schooners, steamers and barges moved through one of the busiest waterways on Earth. And in the middle of all that motion, they were trying to build something that could not move at all. That was the problem, not the legend, not the postcard. The problem. How do you plant a pair of giant stone towers in a tidal strait crowded with ships, then build them so high and so true that they can carry the longest suspension span in the world? How do you hold stone over water, line by line, block by block, until mass becomes geometry and geometry becomes trust? And what did it demand of the workers who stood on wet timber staging, who rode swinging loads, who climbed unfinished arches, who descended into compressed air chambers beneath the river so that the towers could ever begin? The Brooklyn Bridge was not built because people wanted a monument. It was built because the old arrangement of the harbor was failing under the weight of a new century. In the middle decades of the 19th century, Manhattan and Brooklyn faced one another across the East River as separate cities, bound by commerce and habit, but divided by water. Ferries crossed constantly, carrying workers, merchants, horses, carts, letters, food, news, and raw materials. But the river was crowded, dangerous, and unreliable. It was thick with shipping. New York Harbor had become one of the great ports of the world. Warehouses lined the waterfront. Piers multiplied. Traffic pressed from both shores. In fog, in ice, in storms, in winter crush and summer heat, the crossing was a bottleneck in the life of a growing metropolis. So the bridge mattered before a single stone was raised. It mattered economically because capital and goods were moving faster than ferries could comfortably carry them. It mattered geographically because the two cities were separated by a waterway that was short on a map and difficult in reality. It mattered politically because a fixed crossing promised power, prestige, and advantage. And it mattered emotionally because in the industrial age, Americans had begun to believe that engineering could be a national language, a way of proving that a restless republic could build with the scale and permanence once claimed by empires. The man who first imagined the bridge in its final bold form, John Augustus Roebling, understood that scale. He had spent years designing suspension bridges and had learned that grace without stiffness was dangerous, that beauty had to be argued into existence by mathematics, by materials, by redundancy. His East River Bridge would use steel wire in its cables and a great web of stays and trusses to steady the deck against wind and load. It would be immense, it would be expensive, it would be difficult in ways no previous American bridge had been difficult. And before construction truly began, Roebling was dead, fatally injured near the ferry slip while taking final measurements. The bridge passed to his son, Washington Roebling, still young, brilliant, and about to be tested far beyond ordinary engineering. Before the towers could rise, the river had to be persuaded to give up its bottom. That meant caissons, immense open-bottom timber chambers, iron-bound, weighted, and sunk into the East River mud. They were not delicate devices. Each was roughly 102 feet wide and about 170 feet long, a vast wooden box turned upside down and forced downward by its own growing burden. Compressed air was pumped inside to keep the water out. Men entered through airlocks and worked at the riverbed with shovels, picks, wheelbarrows, and, when needed, explosives. As they dug away mud, sand, clay, gravel and boulders, the caisson slowly settled under the accumulating weight above it. On the Brooklyn side, it went down more than 44 feet below high water. On the Manhattan side, where the conditions were harder and deeper, it descended more than 78 feet. It is impossible to understand the towers without understanding that they began in darkness. The public would remember the Gothic arches in sunlight, the vast cables against the sky, the promenade and the view. But the workers first knew the bridge as heat, pressure, timber, foul air, and fire below the river. In the caissons the temperature climbed, the lamps smoked, and the sound of tools traveled strangely through the compressed atmosphere. Men stripped down because of the heat. They stood in wet muck and swung shovels in a chamber where every breath felt different. The deeper they worked, the more the pressure changed them. When they came up too quickly, nitrogen came out of solution in the blood and joints. They did not yet understand the chemistry. They knew the pain, paralysis, vomiting, chills, cramps, slurred speech, knifing pain in the limbs, what came to be called caisson disease, the bends, crippled laborers, and nearly destroyed Washington Roebling himself. One of the first known workers to die from the bends on the project was a German laborer named John Myers in the spring of 1872. He was not a celebrated engineer. He left no famous memoir. He was one of the men the bridge consumed quietly, and there were others after him. Irish workers, German workers, riggers, masons, laborers, whose names appear only in fragments, if at all. The exact death toll is uncertain. At least 20 men died during the making of the bridge, likely more. Records were incomplete. Accidents went undercounted. The great structure that later seemed inevitable rose through a fog of suffering that was never fully catalogued. And yet the work continued. Fires broke out in the caissons. On the Brooklyn side, a blaze smoldered and delayed progress for months. On the Manhattan side, greater depth meant greater danger. Compressed air labor was so punishing that workers struck in 1872 for better pay for caisson shifts. They were threatened with replacement, and many returned. That, too, was part of the bridge. Industrial America liked to remember visionaries, not bargaining men with damaged joints and no leverage. If you value stories that keep that labor visible, consider subscribing, because the world we inherit is full of structures that are remembered by name and built in anonymity. When the caissons finally reached firm enough ground and were filled, the work of making the towers truly began. Above the timber chambers, engineers laid massive grillages of yellow pine, then concrete, then the first masonry courses. The bridge towers were not single stones but organized mountains, carefully composed. Below the waterline, limestone formed the hidden mass. Above it, granite rose course by course. The limestone came from quarries in Essex County, New York. The granite blocks were quarried and shaped on Vinyl Haven Island, Maine, then shipped by schooner to New York. Thousands of loads came by sea. Each block had to be cut, dressed, marked, transported, hoisted, and set into a precise place in a system that tolerated very little error. This was work done by hand, though never by hand alone. That distinction matters. Human muscle did not replace machinery. It worked with it, through it, against it. Steam engines powered hoists. Derricks lifted a stone, but every movement still depended on men reading a load, feeling a line, signaling an engine, guiding a swinging block into place, checking alignment, dressing a stubborn face with hammer and chisel, spreading mortar, adjusting bearing, and knowing from sound and touch whether the stone had seated as it should. The Roebling office produced templates for individual stones. Mortar joints were kept thin, often about half an inch, using Rosendale cement, the natural cement that helped bind so much of 19th-century American masonry together. The granite above the floor was deliberately textured, rusticated, and powerful, while the arch faces and selected surfaces were toiled more smoothly to sharpen contrast and line. Even the surface finish was an argument about strength. Imagine one of those days on the tower staging. A schooner unloads granite at the waterfront. Blocks, already roughly shaped at the quarry, wait like pieces of a dismantled cliff. A derrick creaks overhead. Hemp rope tightens. Iron hooks bite. Steam breathes from an engine. A signalman watches the load rise, twisting slightly as it clears. Masons in caps and rough clothes stand ready on planked staging, darkened by river mist and mortar water. A block comes in slow. Men with bars and gloved hands coax it, not too fast, not too far, until it hovers above its bed. Below lies cement, damp and grey. Beside it, a neighbouring stone waits with its drafted edge already true. Someone shouts, someone steadies the swing, the block lowers, wood wedges, pry bars, taps of the hammer, a check by eye, another check by line, then the weight settles, another few tons added to a tower that must eventually carry the pull of 4 enormous cables. The scale of the masonry was almost absurd. At the high water line, the towers measured about 140 feet by 59 feet, broad enough to feel less like pillars than fortresses. Each contained tens of thousands of cubic yards of stone. Their pointed Gothic arches, soaring high above the water, were not ornamental afterthoughts. They were passages for the roadway and a public face for structural mass, a language of medieval form translated into industrial infrastructure. The towers looked ancient even as they announced something new, that modern engineering did not have to present itself as bare utility. It could carry the authority of a cathedral and the force of a machine. But the men who placed those stones did not work in abstraction. They worked in weather. Summer glare off the water could be blinding. Wind climbed the unfinished heights and made staging shiver. Winter shut down some operations and slowed others. Hands numbed, mortar stiffened, rain turned planks slick. The higher the work rose, the smaller the workers appeared to those on shore, and the larger the consequences of a mistake became. A slipped line, a failed boom, a loosened stone, a missed footing on a beam, and gravity did the rest. In October 1871, before the towers were complete, a pair of derricks hauling granite on the Brooklyn side failed catastrophically. Several men were killed or mortally injured. One rigger, John French, died in a horrifying instant. Others were crushed or fell trying to escape. Such accidents were not exceptional intrusions into the project. They were among the ordinary possibilities of the work. Later, workers would fall from the towers themselves. Others would die when stones dropped or when cables snapped during later phases of construction. The danger changed form as the bridge advanced, but it never disappeared. The workers came from many backgrounds, but a large number were immigrants, especially Irish and German, with others besides them. Some were highly skilled stonecutters or masons, some were riggers. Some were labourers doing whatever the day demanded. Some had worked docks and foundries, some knew quarry work, some knew almost nothing at first, except how to endure. Most were paid modest daily wages. Their bodies were their tools, their insurance, and their collateral all at once. If the work broke them, the bridge continued. A collective portrait comes closer to the truth than any invented hero. Picture the mason on the Brooklyn Tower in 1874, boots white with stone dust, hands raw from handling dressed granite, looking down through the open frame of scaffolding at tug wakes crossing the tide. Picture the labourer climbing before dawn, dinner pail in hand, knowing that one loose fragment or one misjudged swing of a load can end a life at noon. Picture the caisson worker resurfacing with his joints already burning, not yet knowing whether the pain will pass by nightfall or settle into permanent damage. Picture the rigger balancing on a timber beam, one arm wrapped around a line, the city widening beneath him as if the air itself were another river he had to cross. That is how the towers were built by hand, not by some mythic simplicity, but by thousands of repeated acts of coordination between skill, material, and risk. Stone was selected, measured, quarried, moved, cut and bedded. Timber staging was built and rebuilt as the work rose. Derricks climbed with the masonry. Hoisting engines had to be positioned, fueled, maintained, and obeyed. Mortar had to be mixed and used before it failed. Courses had to be kept true. Loads had to be balanced. The arches had to be formed so that their geometry held under their own weight while the work was still incomplete, and all of it had to happen while the river remained open to traffic and the city around it kept making demands. By mid-1873, the towers were visibly advancing. By August 1874, the arches of the Brooklyn Tower were complete. By June 1875, the last stone on that tower had been raised. In July 1876, the Manhattan Tower was finished. The towers took roughly 3 years to complete and stood higher than the tallest office buildings in New York. People could now see what the bridge would be. Until then, it had been a scandal to some, a gamble to others, an engineering obsession to its advocates. With the towers standing, it became undeniable. 2 giant masonry piers now faced one another across the East River, and the space between them began to feel conquerable. Yet the bridge was still far from done. Massive anchorages had to secure the cables on land, wire had to be spun across the river, catwalks had to sway between the towers high above the current. Men known as cable spinners worked on narrow footways in the air, supervising the passage of thousands upon thousands of steel wires that would become the 4 great cables. This phase brought its own terror. In 1878, a strand parted near the Manhattan anchorage and killed workers below. Worse, a steel wire contractor supplied inferior material, forcing the company to replace tons of cable and casting doubt over the integrity of the whole enterprise. By then, the bridge had already consumed 14 years, and doubt had become one of its principal materials. Money deepened the strain. The final cost reached about $15.5 million in 1883 dollars, a vast sum for the time. Brooklyn paid most of it. Delays, accidents, corruption, procurement troubles, and changing conditions all added to the burden. The bridge was built in the age Americans later called the Gilded Age, when engineering ambition and speculative finance often walked together, when political machines hovered over public works, and when the language of progress was routinely paid for with other people's lungs, backs, and nerves. The Brooklyn Bridge belonged to that age completely. It was noble and exploitative, visionary and brutal, elegant and improvised. It was modern in exactly that uncomfortable way. Washington Roebling, the chief engineer, spent much of the later project debilitated by the very compressed air work that had made the towers possible. From his home in Brooklyn Heights, he watched the bridge through field glasses and sent instructions to the site. Emily Warren Roebling, his wife, became indispensable in carrying those instructions, interpreting technical matters, and maintaining continuity between the apartment, the office, and the work itself. The bridge was not saved by romance, but by administration, memory, discipline, and the refusal to let a project of this size come apart when its center had been physically broken. Great structures are often imagined as acts of singular command. In reality, they survive because many people keep translating intention into labor after the original force has weakened. By the time the deck and approaches were completed, the bridge no longer belonged only to its engineers, it belonged to public anticipation. People on both shores had watched it grow for years. They had seen the towers rise like stone gateways out of the river. They had watched cables gather in the air like drawn lines of fate. They had read about deaths, delays, fires, and fraud. They had crossed by ferry, beneath the unfinished work, and looked up. The bridge had become more than infrastructure. It had become a civic trial. Would the thing actually stand? Would it justify the cost, the time, the dead? On May 24, 1883, it opened. Schools and businesses closed. Crowds gathered. President Chester A. Arthur attended the celebration. Emily Roebling crossed in the first carriage from Brooklyn, carrying a rooster as a symbol of victory. The longest suspension span in the world was now real. The East River had not been abolished, of course. Ships still passed, tides still ran, but the crossing had been transformed. What had once depended on boat schedules, weather, congestion, and accidents was now fixed in stone, steel, timber, and wire. Manhattan and Brooklyn were tied together in daily life more tightly than ever before. Trade accelerated, commuting changed, land values shifted. Urban growth reorganized itself around a new certainty. And something else changed as well. The towers altered the mental horizon of the city. They proved that American engineering could operate at a scale once thought fantastic. They showed that infrastructure could be monumental without ceasing to be useful. They stood in a neo-Gothic silhouette above a commercial republic and made labor visible, if only for a moment, in the form of completed mass. The bridge inspired poets, painters, photographers, and promoters, but its deepest meaning was less poetic than physical. It changed what people believed could be built, and therefore what they would next demand. Today the Brooklyn Bridge carries vehicles, cyclists, and pedestrians where once it bore horse-drawn traffic, trains, and trolleys. It has been repaired, widened, strengthened, and continually maintained. The city around it has grown almost beyond recognition. The harbour is quieter than it was in the 19th century, though the river still moves with the same indifferent force. Tourists walk the promenade, where Roebling predicted a path of incalculable value in a crowded city. They stop for photographs between the cables. They look through the arches. They admire the skyline. Many of them feel awe, and they are right to feel it. But awe can become a kind of erasure if it remains too clean, because the towers were not abstract achievements. They were lifted out of the quarry and riverbed by men who hauled, cut, aimed, braced, climbed, and endured. Their names survive unevenly. Some are known because they died violently enough to be reported. Most passed into the bridge, as labor passes into nearly everything durable, absorbed, structural, and forgotten. If you have ever crossed the Brooklyn Bridge on foot, or looked up at those stone towers and wondered what they cost in sweat and nerve, tell me in the comments. The story is never only about the finished object, it is in what the object persuaded human beings to do.